Somewhere under a mountain in Iran, there is a room no bomb was ever supposed to reach. To destroy it,
US President Donald Trump is threatening to bomb a new nuclear site in Iran.
the United States didn't build a bigger missile. It built a bomb 30,000 pounds heavy, designed for exactly one kind of target. This one. Think about how strange that is. Not a new fighter jet, not a new missile. A single bomb, so specialized, so enormous, that an entire aircraft had to be chosen just to carry it. All because of what a group of engineers decided to build into the side of a mountain in the desert. And here's the twist. When that bomb finally fell, the world still couldn't agree on whether the mountain won. This isn't a story about a weapon, it's a story about construction. About the moment engineers decided the safest place on Earth wasn't behind steel, and it wasn't behind concrete, it was under rock. A lot of rock, enough rock to swallow a bomb whole. Today, we go inside the most protected building project on the planet. How it was dug, how deep it really goes, and why no one, even now, can say for certain what's left of it. Let's go inside.
Presented detailed evidence to the IAEA demonstrating that the Islamic Republic of Iran has been building a covert uranium enrichment facility near Qom for several years.
September 2009. In front of the world's cameras, 3 leaders from the United States, Britain, and France stood together and announced they had found something Iran was never meant to reveal. A second enrichment site, hidden, half built into a mountain near the holy city of Qom. Its name, Fordow. Now, to understand why this was such a shock, you have to understand what Iran already had. Out in the open, at a place called Natanz. Natanz was known, Natanz was watched. But Natanz had a problem, a construction problem, not a political one. It sat close to the surface, exposed. Its most sensitive halls were shallow enough that, from the air, they were vulnerable. And after watching what had happened to other nuclear programs around the world, facilities that were bombed, sabotaged, wiped off the map from above, Iran's engineers seem to have reached a simple, chilling conclusion. Wait, what if the building itself could be the armor? That single idea is what built Fordow. Not thicker walls, not more concrete poured on top. A mountain, placed between the facility and the sky. And here's the part that makes it a genuine engineering story. The construction wasn't hidden by accident. It was hidden by design. The secrecy and the structure were the same decision. To protect the site, you buried it. And to bury it, you had to hide it. One choice did both jobs at once. The world had caught Iran mid-build. But catching it didn't stop it. Because by the time the cameras were rolling in 2009, the hardest part of the work, the part that mattered most, was already deep inside the rock, where no camera could follow. Here's the challenge no ordinary contractor ever faces. You don't build Fordow on the ground, you build it inside solid rock. And that changes absolutely everything about how construction works. For years, satellite images tracked the work from hundreds of kilometers above. Analysts watched tunnel entrances get cut into the mountainside. They watched spoil piles, heaps of excavated rock, grow larger and larger outside those entrances. The telltale waste of a massive dig. They watched ventilation shafts appear along the ridge above. In a strange way, people on the other side of the planet were reverse engineering a construction project they were never invited to see, reading the story of the build from the rubble it left behind. So how do you actually do it? The process starts with tunneling. Crews drive access tunnels horizontally into the flank of the mountain, wide enough for trucks, for heavy equipment, for everything a working facility needs to breathe. These aren't narrow mine shafts. They're roadways into the heart of the rock. Once you've reached the point where the mountain above you is thickest, the real work begins. You stop going forward, and you start carving outward. Crews hollow out large chambers directly from the stone. Halls big enough to hold an entire industrial operation. Those raw caverns are then reinforced, sealed, and fitted out as clean, functional working space. Now think about what that actually means for the people building it. Every single ton of rock removed from those halls had to come back out through the same tunnels it went in by. Every cable, every air duct, every generator, every piece of machinery, every wall panel. All of it had to travel in through one narrow throat of stone, lowering finished walls neatly into place from above. There is no open sky to work under. The mountain is the wall, the roof, and the ceiling, all at once. And the deeper you go, the harder every ordinary problem becomes. Ventilation, because rock doesn't breathe and neither can workers without forced air. Power, dragged in through those same tunnels. Water, and the constant, grinding fight against heat and dust in a sealed, enclosed space where there's nowhere for either to escape. A building on the surface breathes on its own. A building inside a mountain has to be given lungs. So Fordow wasn't just dug, it was engineered to be lived in and worked in for years. That's the part people miss. Anyone can dig a hole. The achievement was building a place that could function, day after day, under the crushing weight of an entire mountain. Public estimates from analysts have generally placed the main halls under roughly 80 to 90 meters of rock. But let me be completely honest with you, because it matters. No one outside Iran knows the exact figure. Nobody. And you should distrust anyone who states it to you like a hard fact, because that number has never been officially confirmed. It's an estimate. Read from the outside. And yet, even the low end of that range tells you everything you need to know about the intent. 80 meters of solid rock is not a roof. It's not a ceiling. It's a shield. Stack roughly 25 modern houses on top of one another and bury the bottom one. That's the kind of stone we're talking about, sitting between the halls and the open sky. To understand why depth matters so much, you have to understand the physics of what it's defending against. A bomb dropped from the sky does its damage in two stages: the penetration and then the blast. Before it can explode where it hurts, it first has to get there. Soil slows a warhead down. Concrete slows it down more. But dense rock does something crueler than either. Rock forces the weapon to spend its energy grinding, shattering, and burning its way through the mountain long before it ever reaches the room you're trying to protect. Every meter of stone is a tax on the bomb, and if there are enough meters, the bomb goes bankrupt before it arrives. So the construction strategy here is almost elegant in how simple it is. Don't try to out-armor the bomb. You'll lose that race, because someone can always build a bigger bomb. Instead, make the bomb travel so far through solid stone that, by the time it finally arrives, there's nothing left of it to deliver. You don't defeat the weapon. You exhaust it, and then you add everything else on top of that core idea. Blast doors reportedly built to seal the halls off from a shockwave. Entrances angled into the rock, rather than facing straight up at the open sky, so there's no clean vertical shot into the heart of the facility. Put it all together, and you have a building where the single most important material, never welded, never delivered by a single truck. 100 million years before the first engineer ever arrived with a drill. Or who? That's the quiet genius of it, and the quiet horror of it. The best defense in the entire structure was one nobody had to build. They just had to hide inside it. Now the other side of the story. Because here's what always happens. If you build the perfect underground fortress, then somewhere, in a quiet room on the other side of the world, someone starts designing the one thing built to beat it. That thing is called the GBU-57, the Massive Ordnance Penetrator. And it is not a normal bomb, not even close. It weighs around 30,000 pounds. But here's the surprising part. Most of it is casing, a long, dense, hardened steel body, shaped like a spear, built for one purpose above all others: to survive slamming into solid rock at tremendous speed without shattering on impact. A normal bomb hitting a mountain would simply break apart. This one is designed to stay whole. The logic behind it is almost brutal in its simplicity. You drop it from very high altitude, and you let gravity do the work. Height becomes speed, speed becomes force, and that force turns the entire bomb into a drill. It punches down through layer after layer of earth and stone, driving itself deeper. And only then, once it has burrowed as far as it can go, does it finally detonate, deep underground, where the target is hiding. And you have to understand why a weapon like this even exists. It exists, in large part, because facilities like Fordow exist. This is the arms race made physical, made literal. One side building down, further and further into the earth. The other side building a weapon heavy enough and hard enough to follow it down. A mountain of defense, and a spear designed for that exact mountain. Each one is the answer to the other. And here's the detail that really shows the scale of it. This bomb is so enormous that only the largest bomber in the entire American fleet can even carry it. Just 2 at a time. So picture that whole chain for a moment. An entire aircraft, an entire weapons program. Years of engineering, and billions of dollars. All of it shaped, ultimately, around the construction choices made inside one buried facility in the Iranian desert. One building, on the far side of the planet, quietly bending an entire air force around its design. For years, all of this was theory. A fortress that had never been truly tested, and a bomb that had never been used against the one target it was built for. In June 2025, the theory was finally put to the test. American strikes hit Iran's key nuclear sites, and Fordow, the mountain fortress itself, was reported to be a central target. Reports described bunker busters, the very weapons built for this job, being used against the mountain. And then came the strangest part of this entire story. Nobody could agree on what actually happened underground. Some assessments claimed the facility had been severely damaged. Other assessments suggested the deepest halls may have survived the strikes, or that critical material had already been quietly moved out beforehand, before the first bomb ever fell. And these weren't small disagreements settled in a day. The damage assessments were disputed for weeks. Wait, what? But here's why they were disputed. And it's the most poetic thing about the whole build. The one feature that made Fordow so brutally hard to bomb in the first place, all that rock, all that depth, is the exact same feature that made it almost impossible to see inside and confirm afterward. The mountain that stopped the bombs from getting in also stopped the world from looking in. And so the construction ended up doing something its builders may never have fully intended. Even under direct attack, even after the largest conventional bombs in the arsenal came down on it, the mountain protected the site's very last secret, the truth of its own condition. Whether it lived or died became, itself, a thing buried under the rock. So step back from the bombs and the politics for a second and look at just the engineering. Look at the decision that started all of this, back in 2009. Maybe the question was never really, can you destroy it? Maybe the real question is the quieter one. The one engineers have arguably been asking ever since the world first saw those satellite images. When a nation is willing to build an entire mountain around its single most important room, is there any bomb, of any size, that truly ends the story? Or does the mountain always keep one last secret, no matter what falls on it? That's the strange legacy of Fordow. It turned a mountain into a machine. It turned dirt and stone into the most valuable armor on Earth, and it forced the most powerful military in the world to build a weapon around a single hole in the ground. Here's a quick question for you. Tell me in the comments. I read them all. And if you want more stories about the things nations build in secret and the raw engineering behind them, subscribe to Buildora, because there's a whole world buried underground, hidden inside mountains and beneath deserts. And honestly, we're only just getting started.